Okay, so now we're going to find the coordinates of the orthocenter of a triangle. So the orthocenter is where your altitudes intersect. So remember, your altitude passes through the vertex of the opposite side. And it's going to be perpendicular to the opposite side. So you pick a side, you find the slope of the side, and you're going to use the opposite reciprocal of the slope, since it's going to be perpendicular to that side, and then the point that it has to pass through is it has to pass through that vertex. So this problem kind of guides us through it. So first it says find an equation of the line that contains the altitude from G to FH. Well, FH is our side. It's a horizontal line. So if this is a horizontal line, our altitude is going to be a vertical line. So it's going to be that vertical line that passes through the opposite vertex, which is G. So it's going to be this vertical line that passes through G. If it's vertical, if you remember Hoy-Vux, if it's vertical, it's x equals, and I can just go look on this graph. G is at 2, 6, so it's x equals 2. So that's the first altitude, is this vertical line, x equals 2. Then find the equation of a line that contains the altitude from H to FG. So this is where it gets a little bit more complicated. I am going to have to find a line that's perpendicular to FG that passes through H. So first I need to figure out, well, what's the slope of FG? So I can either count it or I can use the slope formula. I'm just going to count it since I have a graph right here. Up 1, 2, 3, 4, 5. Up 5 over 1, 2, 3, 4, 5. So up 5 over 5 reduces to 1. So if the slope of FG is 1, then the opposite reciprocal slope, since it's going to be perpendicular, the opposite reciprocal slope is going to be -1, and it has to pass through point H. So I got my slope, I got my point, and so now I can plug that point and that slope into point slope. So it's going to be y minus 1 equals -1 times x minus 4. I can put it in slope-intercept form if I want to, but I'm just going to leave it in point slope form because why do more work if I don't have to? So this is a slope of 1, so I'm going to go, or slope of -1, I'm sorry, so it's going to look like that. So it's this line right here, and I can clearly see that those two altitudes intersect at this point right here. Sometimes it's not going to work out quite so pretty, so what I can do is I'm going to solve this system of equations. Well, I already know that x is 2. I can go plug 2 into this equation in for x. I can go substitute the 2 in for x to find y. So I'm going to have y minus 1 equals -1 times 2 minus 4. Y minus 1 equals -1 times 2 minus 4, that's -2. So y minus 1 equals -1 times -2 is 2, and then I'm going to add 1 to both sides, and I get y equals 3. So I know my x coordinate is 2, I know my y coordinate is 3, and so the coordinates of the orthocenter should be 2, 3. The x coordinate's 2, the y coordinate's 3, and if I go look on this graph to the right and then up 3, 1, 2, 3, ding, 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 that's exactly where my orthocenter appears to be on the graph, and I can verify it by plugging 2 into this equation of the altitude and solving that system of equations. So I find the two equations of the altitude, either graph them or solve the system of equations to find their point of intersection.